Problems to solve second order homogeneous linear partial differential equations. Solve 2r minus s minus 3t equal to 5e power minus x 5e power x minus y. So r is dou square z by dou x square, s is dou square z by dou x dou y, and t is dou square z by dou y square. Substituting and writing the operators. And now replacing the operator notation, dou by dou x is d and dou by dou y is d dash. So here we get 2d square minus d dash minus 3d dash square into z equal to the right hand side 5e power x minus y. Further, now we have to solve the equation. So we should first find complementary function and then particular integral. So for which we have to write the auxiliary equation. So put d equal to m and d dash equal to 1 in this equation. That will give us 2m square minus m minus 3 equal to 0. Factorizing 2m square minus 3m plus 2m minus 3 equal to 0, we will get 2m minus 3 into m plus 1 equal to 0. Hence, the roots are m equal to minus 1 and 3 by 2. Okay, that is the roots are real and distinct. So, when the roots are real and distinct, we should find the complementary function using the formula CF equal to y plus m1x plus f1 of y plus m1x plus f2 of y plus m2x. So, here m1 is minus 1. So, y minus x plus f2 of y plus m2x. m2 is 3 by 2. So, y plus 3 by 2 x. Now, the particular integral, to find particular integral, 1 by 2d square minus d dash minus 3d dash square into 5 e power x minus y. So, 5 into 1 by d plus d dash into 2d minus 3d dash e power x minus y. So, whenever we have exponential function, we are writing the quadratic equation as in factors. Okay. So, if f of d dash is equal to 0, then particular integral is 1 by g of ab into x power m by b power m into m factorial e power ax plus b. We are going to use this because we have to put d equal to a and d dash equal to b. Here a is 1. So, d is 1. D dash is equal to b. b is minus 1. So, 1 minus 1 becomes 0. So, the denominator becomes 0. Hence, we are going to use this formula. Okay, and we see that there is one 0 factor and this does not become 0, and that is g of ab. So, my 1 minus 1, that is a. Coefficient of x is a and that is d value. Coefficient of y is b and that is d dash value. So, while by substituting this, d plus d dash term becomes 0. 1 minus 1 becomes 0. However, here 2 minus of minus 3, that is 2 plus 3 becomes 5. Therefore, g of ab is 5 and x power m, there is only one 0 factor. So, m is 1. So, x power m by minus 1 power 1 into 1 factorial e power x minus y. Hence, the particular integral is minus x e power x minus y. And final answer, complementary function plus particular integral. Okay. Now, second problem, solve d square plus 2d d dash plus d dash square into z equal to 2 cos y minus x sin y. Okay. So, first write the auxiliary equation, put d equal to 1, d dash equal to m and d dash equal to 1. So, auxiliary equation will become m square plus 2m plus 1 equal to 0. That is m plus 1 whole square equal to 0. That is m equal to minus 1 minus 1. So, complementary function is f1 of y minus x plus x f2 of case 2, because roots are real and repeated. So, f1 of y plus mx, m is minus 1. So, minus 1x minus x plus x f2 of y minus x. Now, to find particular integral, 1 by d square plus 2d d dash plus d dash square into 2 cos y minus x sin y. So, we have to separate the functions and then find the particular integral. So, it becomes 2 into 1 by d square plus 2d d dash square, okay, plus d dash square into cos y minus 1 by d square plus 2d d dash plus d dash square x sin y. Okay, so for this we have to find the particular integral. So, by finding particular integral, what happens? We have to put d square, it should be in the form of cos of ax plus b. So a is 0, b is 1 because coefficient of x is 0. There is no x term. Coefficient of y is 1. Similarly, okay, so for this we should use function of xy, that is case 4. Here we are using case 2. So what happens? D square is minus a square, that is 0. D dash square is minus b square, that is minus 1. But d dash is 0 into 1, 0. Hence, particular integral is minus 2 cos y. So this is the particular integral. So for the first term it is found. Now we have to proceed to find for the second term. Now for the second term it is a function of x and y. So we should use case 4. To use case 4 we should write it in the form of 1 by d minus md dash. Okay, so we are writing the given quadratic equation in the form of d plus d dash into d plus d dash. So first we will apply for d plus d dash. So it is in the form of d minus md dash. So when we compare d plus d dash and d minus md dash, m is equal to minus 1. Okay, so if m is minus 1, c is equal to y plus mx. So if c is y plus mx, m is minus 1. Then c becomes y minus x. That is c. So if c is y minus x, then y is c plus x. Yes. So x sign in place of y, replace it by c plus x dx. Now integrated by parts. Yes. So the solution of 1 by d plus md, d minus md dash function of xy is equal to integral of x sine function of x. Okay. So it is f of x function of x dx. So it becomes integral, the solution of this is integral x sine y replaced as c plus x dx. So integrating it by parts, we will get minus x cos y plus sin y. But we still have minus x into minus cos c plus x minus 1 into minus sin c plus x. But c plus x is nothing but y. So replace it back again, substitute again. Then we'll get minus x cos y plus sin y. Okay, but we have one more factor here, d plus d dash. So for one factor we applied and we got this solution. So we have to apply it for another factor, d plus d dash. Now it becomes integral. So again m is minus 1. So already we used c. So now we can use another constant d. Then what happens? Minus integral minus x cos d plus x plus sin d plus x dx. Now that is equal to minus 2 cos y. Alright. So integrating it by parts, we will get minus x sin d plus x minus of minus cos d plus x. Okay. So that is integration by parts for these two functions. Again, integral of sin d plus x is minus cos d plus x. But however, d plus x is nothing but y. So substituting minus 2 cos y minus of minus x sin y plus cos y minus cos y. So removing the brackets, minus of plus becomes minus. So minus cos y. Yes. And minus cos y. Yes. So it becomes minus of minus cos y minus cos y becomes minus cos y, that is plus 2 cos y. So minus 2 cos y plus x sin y plus 2 cos y equal to x sin y. So these two terms get cancelled. Yes. And it becomes x sin y. So solve. Next problem. Solve d square minus 2d dash plus d dash square into z equal to 12xy. So auxiliary equation is m square minus 2m plus 1 equal to 0. M minus 1 whole square is equal to 0. And m is equal to 1, 1. Roots are real and repeated. So complementary function is f1 of y plus x f2 of y plus x. Okay, particular integral 1 by d square minus 2d dash plus d dash square into 12xy. Into 12xy. So 12 into, it is polynomial function, so we should take inverse and solve. So 12 into 1 by d minus d dash whole square into 12xy. That is, take d square common from this. It becomes 12 into 1 by d square into 1 by 1 minus d dash by d whole square xy. That is 12 into 1 by d square into 1 minus d dash by d power minus 2 xy. So what happens? We should expand it. After expanding, we will get xy plus 2 into 1 by d plus d dash into xy. So we know that 1 minus d power minus 2 is 1 plus, both are minus. Okay, so the expansion will be positive series and it will be 1 plus 2d plus 3d square minus plus 4d cube, etc. So using that expansion we get this, and then we have to apply. When we are applying, we should apply the numerator operator first and then apply the denominator operator. That is, first we should differentiate and then we should integrate. Alright. So d dash of xy. D dash means partial derivative with respect to y. It will be x. Of this function xy will be x. And then integrate x, it becomes x square by 2. Okay. Again we have 1 by d square outside, which means integrating the function twice. So we should integrate the function twice and we get the solution 2x cube y plus x power 4. Now fourth problem, solve d square minus d dash minus 2d dash square into z equal to y minus 1 e power x. Auxiliary equation is m square minus m minus 2 equal to 0. By factorizing, we will get m equal to 2 minus 1. Roots are real and distinct. So for complementary function is f1 of y plus 2x plus f2 of y minus x. Now right hand side is y minus x into e power x. That is, it is a function of x and y. Case 4. So we should write the quadratic equation as factors, and then for each factor we will apply it. Now taking this factor d minus 2d dash. Okay. So first we will apply for this factor d minus 2d dash. Then what happens? Here m is 2. So if m is 2, okay, c is equal to y plus 2x. If c is y plus 2x, y is c minus 2x. So substituting for y, c minus 2x, y minus 1. So c minus 2x minus 1 into e power x dx. And then removing the brackets, okay. So we will get c e power x minus e power x minus 2 x e power x. X e power x integral is x e power x minus x. Okay, so we will get the solution. And then we have to again group it in terms. Again substitute for c. C is y plus 2x. So we get back. So after we get back this, we should then apply it for d plus d dash term. Now what happens? Okay, so we will get y plus 2x e power x minus 2x e power x plus e power x. Here m is minus 1, d minus md dash. So m is minus 1. Then what happens? If m is minus 1, c is equal to y plus mx, that is c is equal to y minus x. Then y is c plus x. So substituting for y, we will get c plus x e power x plus e power x. Yes, that is equal to c e power x plus x e power x. Okay, so integral of x e power x is x e power x minus e power x plus integral of e power x is e power x itself. Cancelling these two terms, we will get c e power x plus x e power x, that is y minus x e power x plus x e power x. Simplifying the terms, we will get y e power x, that is the particular integral. Hence z is equal to complementary function plus particular integral.